All right, hello everyone. Zach Smith with CS187 Java Programming for New Mexico State University grants. We're going to be talking about Module 6, which deals with logic loops. And before we get started, let's see if anybody has any questions concerning last week or the week before, or just questions in general. Okay, I don't see any hands up. I don't see any messages right this minute. So we're going to talk about logic loops. Now, I do have a visual that I'm going to share, and it's a flow diagram. Now, you've probably seen flow diagrams like this before. You use them in all kinds of things. But specifically, what we want to talk about is this do-while loop. And this is probably one of the simplest, but the most confusing for people. And imagine when you're writing code, and it's called a pseudocode, which means you're using words that express what you're trying to do, but not necessarily functional syntax. And so we have this do-while. And so if you sound it out or say it out loud, it makes sense. Do this while this is true. And it's very important that you look at the difference in those terminologies, because you have three primaries, although a switch and an if statement can be used for looping. The three primaries that we're going to be talking about tonight are the while loop, the for loop, and the do while loop. So a do while loop is let me think about how to state this. So let's start with a while loop. Okay, a while loop repeats a statement, and the statement is your conditions, your conditional code. If you look at the screen right here, that conditional code, and it does that as long as something is true, and that is a while loop. Then you have a for loop, which executes a sequence of statements a number of times until it reaches a particular variable. Usually it's set to a number for something that you're going to do 10 times or 15 times. And then you have a do while that is like the while statement, except that it tests the condition at the end. So a while statement starts at the beginning and says, while this is true, do this. The do while will do whatever you want it to do and then test to see if it's true. So even if it's false, a do while will run one time. And this is very important, because there will be times when you want something to check to see if it's going to work, regardless of whether or not the input is true. Something like maybe check username. And so it'll check the username no matter what they put in there. If it's correct, it'll continue. If it's false, it won't. But it allows you that opportunity to test prior to executing a condition. And a condition is a Boolean process, a true or false, and everything Boolean comes out to a true condition or a false condition. That's it. Now you can concoct all kinds of groups, but ultimately it's always true or false. So the simplest, or the most often used, is a while loop. And let's see here. I'm going to stop sharing for a moment and open Eclipse. Oh yeah, that's in the other classroom. Okay, so what we're going to do is we're going to go ahead and do a little bit of code so that you can start to become more familiar with that. Okay. I'm going to close the part that with your hands up, so if you raise your hand and I don't see it, shoot a message. That will make things run a lot easier. Okay. So the first thing, let's go ahead and create a new package in a new class. So remember, we're going to go to our CS187. We're going to go to source, right click, go to new package. This will become com dot your last name, first initial, and we're going to be working on 6. So we have our new package. Now we're going to go ahead and create a new class. And we're just going to call this loops. Remember your convention, capital. And we're going to go ahead and run that. So now we have a class ready for us to start working with. So a while loop. Remember, a while loop is a conditional. And everything that makes programming work is about using the computer to make decisions based on prior input. That's what we're trying to accomplish, whether it's a mouse click that move here, open a program, if you're dealing with artificial intelligence, where it starts to learn. But everything is about allowing the computer to make decisions based on previous input. Okay, so what we're going to do is we're going to look at a while loop. So first thing that we need to do is we need to declare a variable that gives us a count. And you'll see what we're talking about here in a second. Typically this is an int, and often it's just called count. And it's a counter that tells our while loop how long to do something. Okay, so we've declared our integer, we've called it count, and we have set it to equal 0. Now we're going to go ahead and start our while loop. So we have while. Now while count is, say, less than 10. We're going to work on that right now. And then we have our curly brackets. Notice this is the conditional. This is what makes it true or false. So think this through for a moment. If our count is 7, will this while loop run again? If you said yes, you're correct, because 7 is less than 10. Now, how about 10? Will it run if our count up here is 10? And the answer is no, because 10 is not less than 10. It is, in fact, equal to 10. So it's very important that you begin to understand these. And they can be a little confusing until you get used to it. Okay, so the next thing we're going to do is we're going to go ahead and print a statement that allows us to see what's going on. So remember in Eclipse, and remember this is only in Eclipse, this shortcut. If you're using NetBeans or something like or hand coding, you will have to do system.out.println. Okay, so now we have our print statement, and what we want to do is we just want to see what our program is doing. So we'll do our string. We'll say the count is equal to. We're going to go ahead and concatenate that, so we use the plus sign, and we're going to concatenate that with our count, which is right here. And what we want is that for this number, this right here, to print out our count. And finally, we have to increment our count because we need it to grow. We need to know how many times the while loop has run. And so what we'll go ahead and do is we'll go ahead and do count. And remember, there are 3 ways to do incrementing. You can do count is equal to count plus 1, and that will take the count, whatever the number is, and add 1 to it and assign the new count, which will change this value, which will then test this value. So we're going to start with that one. We'll go ahead and save it, and we run it down here. So as you can see, we have count 0, count 1, 2, 3, 4, 5, all the way through 9. When it got to 10, since 10 is not less than 10, it stopped. All right, good question, Stephen. Juan, yes, we are going to do that. And I wanted just to show the 3 different variables so that everybody can see. The second way that you'll see this written is plus equals 1. which is the exact same thing. And you notice it did exactly the same thing, but for the cleanest code, and the standard is simply your variable plus plus with your semicolon. We'll go ahead and save that one as well and run it one more time so you can see that it in fact does the exact same thing. So when you're doing incrementation, either incrementing or decrementing, which would be negative negative, which would subtract 1, go ahead and use this method right here. So let's change this real quick so you can see. So let's say that we change this to 5 and we change this to 13. So quickly calculate, what is it going to show us? Everybody take a moment and think about that. All right. If you said 5, 6, 7, 8, 9, 10, 11, 12, and stop there, you're correct. Let's look at this. Let's go step by step. So our count started at, in this case, 5. It comes down here and it says, is count less than 13? Yes, it is. Since that is true, print count and the count, which was 5. And then it comes down here and adds 1 to 5, and it changes in memory this to 6. Starts again. Count is now 6. Is count less than 13? Yes, it is. Since that's true, print this, add 1 more. And you can see each of those steps. So hopefully you can see really quickly how you can start to do you can really start to do some advanced mathematics. You can do a lot of printing with this function. And anything really that you can come up with, you can use it. Now, of course, this is just the simple version here. But we could do something like this. We could say, well, what if we want to add, let's say we want to add count times 3, for instance. Now, so count is 5. It's less than 13. Do this times 3. So that means count becomes what? 15. When it comes back around, it's no longer less than 13, so it only prints once. There'll be a lot of situations where you'll come across this. In this next assignment, you're going to use this. So unless there's more questions on this while loop, I'm going to go ahead and continue. Nothing? Okay. So the next one is a for loop. Now, for loops are typically the most confusing and are very powerful. So I'm going to go ahead and comment this out. That way it's still there should we need to come back to it. And we're going to move down and we're going to start a for loop. So first I'm going to write what a for loop looks like. Okay, so we have for. Now we have to initialization. Then we have our, oops, this is a semicolon. We have our condition. And finally, we have our statement. So I know this looks confusing right here. And then, of course, we have our curly brackets following it. So what is our initialization? Well, our initialization is declaring what we're starting at. Remember, in this instance right here, we said int is equal to count, or count, let's try that again. Int count is equal to 5. Okay. Well, here in a for loop, we do it on the inside. And so in this instance, typically you will see int I is equal to 0. Now, this can be anything, this I. It could be whatever you wanted. Watermelon, it doesn't make any difference. Typical convention is to use I, J, K. If you had a for deep loop, just following that continual sequence. So we're going to stay with standard protocol because although anything will work, and there will be times maybe you want to have a special value that's dealing with, maybe you're wanting to assign the value of where it starts with. Then you could call this something else. You could call it start or whatever it is. But here, when you're just doing empty for loops, typically you will see it with an I. Now the second part is a condition. Now the condition is the Boolean condition, which right here was count is less than 13. Now since our variable is I, we would say I is less than 13. And finally, we have our statement. Now, our statement is this part right here. So this is our incrementation, what it's growing by, which is typically, again, I plus plus. So now, this for statement did all of this with the exception of our print line, and we'll still have our print line here. So we'll do sysout, control space, and we'll do the same thing. And then we will add our plus modifier for concatenation, and we will, but this time we're calling it I. So let's go ahead and save this. Let's run. And if you notice, the exact same thing happened. The reason most people consider this to be more complicated is because you're establishing everything right here. Once you get used to it, it's typically easier because you don't have to have those extra lines of code. Yes, Juan, I is the variable name. And typically it's I for increment, I would assume. But you can use anything. I mean, we could redo this. We could call this count if we wanted to. So we could change this count, and change this to count, change this to count, and change that to count. Now we can go ahead and save it and run it. Same thing all over again. Like I said, just generally you will see it. I's, J's, and K's seem to be the two big ones. Now what I want to do here on this one is let's try a pyramid. So you can kind of see it doing something other than counting. Okay, so we're going to go ahead and comment this out. All right, so I'm going to go ahead and say for. The first thing we're going to do is set our variable, integer, I is equal to, I'm going to go ahead and go to 1. We're going to say if I is less than, we'll do 5 for now. And finally, we have our statement, which is just I plus plus. Now, we'll come over here, we'll put our curly brackets. Now we're going to do a second for loop. So again, we're going to do, this time we're going to use J. We'll set that equal to 0. We'll do J is less than I. So what we're doing is we want this inside loop to run only as long as it's smaller than this number up here. And then we will add our increment here. And again, you have to get those curly braces in there. So we have what's called a nested for loop. This for is nested inside this for loop. Sometimes you can get curly brace crazy, so it's good to double check that your curly braces are in the right place. So now what we're going to do is we're going to go ahead and do our sysout. And all we're going to do is we're just going to print an asterisk for now for our J, and you'll get a better sense of it here in a moment. And this one, we're just going to go ahead and print that. All right. So let's go ahead and run this real quick. Make sure we don't get any errors. Okay. So here's what it did. It printed 1 star, 2 star, 3 stars, 4 stars. However, we're trying to get pyramids. And do you see what the problem is? This print line right here is causing every one of the stars to be printed down below. So let's go ahead and run this again. There we go. So we have 1, 2, 3. So we have started building. So let's think about this. All right. So it says for integer I is equal to 1. And when I is less than 5, run this inside loop. So what's going to happen? It's going to run this loop. And then it's going to say, okay, that is true. Now, I is our test here. And so we're going to use J, which is equal to 0, where J is less than I, because I started as 1. That's why we had to have a 1 up here and a 0 down here so that this will run, as this one will always be 1 step larger than the inside. And we're adding to it. And so if this is true, print a star. So when I is 2, that's less than, it will run. So J would be 1. It's less than, so it runs. So it will print right there. So let's make this a little bit bigger. I like bigger. So that would be a 10, let's say. So let's see what happens. There it goes. It continually gets bigger. Part of programming, you have to have, I think, part of that, yeah, let's break it kind of attitude. And you see that this just continually gets bigger and bigger and bigger. Not terribly impressive, but it does give you an example of multiple for loops, nested for loops. Now we could change that if we started with a bigger number here. Let's come over here and make this a smaller number. And rather than add, we're going to subtract, because now the integer is larger and we want to get it smaller. What do you think will happen? Well, let's run it and see if your guess was right. Oh, broke it. What are we missing here? J is 0, yes, yes. Oh, have to change our, there we go. See, got to break it sometimes. There it goes. So was that what your guess was? Did do it upside down? If so, congratulations. If not, don't worry, it takes time. Let's see. Let me think of an interesting one. So, all right, now we have all these stars, but let's say that you wanted to do something where you wanted to print numbers, for instance. How would that work? So you could, instead of printing this, we could print so now we've created our numbers in descending fashion all the way down to 1. This will come in handy when you start doing data analysis, or you're creating random number generators in order to protect passwords, things like that, where you want to be able to create large numbers quickly. Maybe you're doing a test run. there's a lot of situations where you will come across situations for that. Are there any questions on for loops? I had to get powered up by Lemonade. All right. I don't see any. I'm going to, one place I want you to look at and get used to looking for information is a website called java-examples.com. I'm going to post it in the, they have some really fun stuff on there, just simple. And there's nothing wrong with finding a piece of code and duplicating it. Just type it out, because it begins to teach you muscle memory. It also begins to teach you coding memory. You start getting used to patterns, and pattern recognition is very important, because if you're going to hunt for patterns, you also need to be able to recognize them. So although it's not required, I would definitely recommend that you do that. So the last thing we're going to do is a do while loop. And a do while loop is, we did one last week, so it is on the video, but we're going to do another one. Okay. So with a do while loop, like you did with a while loop, we do need to go ahead and start our count. And so we'll just call this one x. We'll say 10. So we've declared the integer x, and we've assigned it the value of 10. Now we're going to do a do while. So do, curly braces, come down here to the last of the curly brace, have a while, and then you'll have parentheses, and of course that is followed by a semicolon. So the first thing is, what do we want it to do? And right now we just want it to print something out. So we'll go ahead and do our print. What do we want it to print? I think Java is cool. All right. So it's going to print that. Then we want it to go ahead and increment. So we're going to go ahead and increment. And let's see, let's go ahead, and in front of this, we're going to go ahead and put our variable and concatenate that in there, so it'll tell us which line it is. And let's go ahead and put a space right there. And then we want it to do this while what is true. This is our conditional. And we're going to say x is less than, well, we started at 10, so let's say 30. Okay, so let's go ahead and save this, and let's go ahead and run it. So if you notice, here's our x value, 10. It ran this. It went ahead and ran it. It printed out line number. I think Java is cool. It added one more to it, and then it tested it. And then it came back up here, set the value, and repeated the process. So we could add something else to this. We don't have to. We could also say, I hope if I get that. So we could also add to that. We could say, let's go ahead and put x plus 3, for instance. Let's see what that does. So work it out in your head. Think about it. And is that what you expected? You expected to start with 10. I think Java's cool. Add 3 to it. Now notice that here, 10 is our 10. I think Java's cool. It adds 3 to x and prints that value, which is 13. And then it adds one more to x. Notice this does not change the value of x. This is very important, because what we're doing is we say x plus 3. We're not telling it to change what the value of x is. We didn't assign it a new value. We just wanted to know what it was plus 3. So x is still the x that was listed here. It adds 1 to it and cycles through it again. All right. So any questions on this? And this is tough. So there should be a couple of questions at least. Okay. All right, well, I'm going to pull up our chapter so we can look at it then. All right, so chapter 6 discussion is discuss the pros and cons of the for loops. And that is FOUR, numeral 4, the for loop, while loop, do while, and the switch case. Now, the switch case is considered to be a loop control. We dealt with that. If you've done lesson 5, you have looked at the switch case, and it's also on our module for last week, so you can go to the website and watch that video if you haven't. So right now, all you're going to do is go through that and discuss the differences, your opinions, your thoughts, pros and cons. It's very important that you understand these different decision-making logical processes. If statements, switch case, for, while, and do while. Everything you do once you get past probably this next chapter will involve one of those or several of those. And you can intermix them, you can nest them. You could say, if today is Monday, do this while it's after 4 o'clock, for instance. So timers, all kinds of things. You can include them one after the other. You can nest them. And I've seen some nests that are 10 different loops thick, and it's horrible to figure out. So if you can avoid nesting more than 2 or 3, it's important to avoid that. All right, let's see here. The quiz. Looks like 10 questions, a couple of true or false. Some brief explanations on string, for loops, the differences between do while, and for. You're going to write a for loop for the quiz, so study up on those. And a couple of new terminologies, nothing too scary. This looks like a pretty simple and clear-cut week. Let me look at our assignments for the week. Assignment 6. All right, so looks like you're going to have to do some research to find the random math function. Very important. You'll use random for all kinds of things, salting passwords, times, mathematical functions, games, especially games. Both for, say, power-ups or how long things work, how fast they work, locations, when a zombie is going to attack, you don't want the zombie to be in the same spot every time. So you're going to use a random math function that picks a new spot for it, or maybe how many, what their strength is, all kinds of stuff. Random is highly, highly useful. And all it does is help you, it just picks a generally random number. And so you're going to have to create a random number generator for loops, while loops, and for switch case. So you will have 3 programs to turn in. Looks like you're going to make a dice game and a guessing game, which is based on the one in your book. So this is a pretty simple week. You guys have it pretty good. Would you like to look at a couple of more just quick little coding projects? All right. Let's see. Let's find one that's interesting. All right, prime numbers. Prime numbers is a really tough mathematical process, surprisingly. So let's go ahead and do that. All right, so we're going to do a program that will find prime numbers. First question is, does everyone understand what a prime number is? Okay, a prime number is a number that is divisible by itself and one only. So 1 obviously is a prime, 2 is prime, 3 is prime, 5 is prime, 7, 11, 13, I think 17, 19, 23, and then I start losing them at that point. So we're going to write a program that'll do it for us. Okay, so the first thing we need to do is determine how many primes do we want to find. From 0 to what? Well, I like big numbers. So let's go ahead and start off with, say, 500. So our goal is to find every prime number from 0 to 500. Okay, so we've set our limit. Notice we can change that at any time. The next thing we're going to do is we're just going to print a message that says prime numbers between 1 and. Now we may want to change the limit, so we don't want to say 500 in there. We have declared a variable. It's always good programming to use that, so we're going to go ahead and put that in here. So first off, let's go ahead and run this. We can see what it does. Run often, and you will be a much happier person. Okay, so we've set it at 500. This prints out and says prime numbers between 1 and 500. Notice if we change that, hold on one second, guys. You want me to let you know that?
Yeah.
Want to stay right here?
Yeah, sure.
Scott showed up. Okay, so if we change that to 600, what's going to happen to our print statement? Well, we run it, and lo and behold, 1 and 600. So we're making proper use of our variables. All right, so the next thing we want to do is, let's go ahead. So we've defined our limit of prime numbers. All right, the next thing we want to do is, now we want to loop. This is where we're going to use our loop. And so we're going to loop through each number 1 at a time, right? Okay, so now we're going to use a for loop. Remember, for, the first thing we have to do is initialize our variable, and don't spell it, it's int. Int I is equal to 1. Then we have to have our condition, which is I is less than. Now, what is it going to be less than? Well, we want it to be less than our limit, right? So let's go ahead and put in our limit there. And then finally, we need to what? Increment, because we're increasing 1 by 1. Right? Now we can go ahead and put in our curly braces. And again, let's test it. So the easiest way to do that is to print a print statement and put in our variable. Right? So we can go ahead and put in 1. And we can test it. Now, I'm going to make this smaller so we don't see 600 numbers go across the screen. We'll just go to 100. So let's save that, and let's make sure that it works. All right, there they are. Every number between 1 and less than our limit, which was 100, right? Okay, so the next thing, this is our test. This is our test to make sure it is working. All right, so the next thing we need to do is we need to go ahead and we're going to set a Boolean. And a Boolean, remember, is what? True or false, right? And we're going to say, is this number prime? If so, make that true. That's what we want, right? We're looking for prime. So now we need to to check to see if prime. That's the next goal. And how are we going to do that? We're going to write another for loop. Now this time we're going to declare our initialization int. We've used I, so it's the next one in line, j. Now here we want this inside to be larger than the outside because we're growing with it and we want it to test what's within the bounds. So if we put a 0 here, this would never be true because it's smaller than our initial variable. So if you're writing these and nothing happens, make sure that your stepping of numbers from one nested loop to the next is correct. And sometimes the only way to know that is just to try it. Okay, so now we have, and we want our I to be our max, right, which is this number. And that I is going to be less than our limit, which is that number. And so finally, and then we need to do our incrementation of j. Okay, so let's look at it one more time. This looks good. We know that it works through here. Our Boolean, we haven't used that, but how do we test to make sure this is working, right? So we do a print statement. Now we don't want to just print the number because we won't know that it's working separate from our other number, so let's do it like this. Let's go ahead and save it. Hey! Don't revert, save, and run. Okay, so now we have our j running right there. Okay, so we know that this is working, so we can go ahead and move this out. Now, finally, we want to test if, in fact, it is a prime number. This sets our limit. This allows us to test everything from 2 to whatever this number is. But now we need to actually make the test. And here we're going to say, if a number is prime, we want it to do something. Otherwise, leave. Right? So we'll go ahead and do if I. And this is, the percent sign is the modulus operator. If you don't know what the modulus operator is, it's called modulus math. And what it does is it divides a number and only gives you the remainder. And so if you're unfamiliar with it, Google it. It's a very, very important mathematical function for anything like this. So what we're saying is, if when you multiply a number, and when you divide a number by another number and it equals 0, we want it to be is prime false, and we'll look at that here in a moment. Okay, and so let's come over here. Let's say, I don't know how well I'm going to be able to do this, so we're going to try it. So let's say that 4. Woo, that almost looks like a 4. So if we divide 4 by I, okay, so that would be our I, and ultimately what we're trying to figure out is if we divide it by, let's say, 2, for instance, what do we get? The number is, oh, wow. Oh, boy, that's horrible, guys. Whew. That's terrible. I was trying to make an equal sign. But so if you divide 4 by 2, you get 2.0, right? 2.0. And what we're interested in is this. This is what we're interested in, basically the decimal. Because that's a 0, that means that it divided equally. What is our condition? Any number that can only be divided by itself or 1 is a prime number. If we can divide it by any other number and get a 0 in our decimal place, it's not a prime. So what we want to know is if any number divided by any other number besides itself or 1 is 0, and that's false. Okay, and now we want to go ahead and break. If you remember break from your switch case from last week, all it does is kicks out the program. It stops right there. It doesn't continue hunting through the. Now, what we want to know is, make sure we have the right amount. If is prime, and this is a really neat function in Java, which we're going to go over real quick. And I'm going to show it to you in a second. We're going to go ahead and print our our concatenation operator. Yes, that's a doozy. And a space. And we want to get rid of our print line because that's going to drop it down. Okay. So what this says is prime true? If it's here, that's the same as saying equals true. Oops. True. However, you don't have to type all that. It just allows you to type is prime, and this assumes that it's always true based on what we wrote right here. So the only time this will work is if prime is true. So a number comes down, gets to here, runs through here. If it has a modulus of 0, it's going to make false, which means is prime will not run. They'll start back up here and go through the next number. If it is true, then it'll come down here and spit this out. So let's go ahead and look at it. Okay. So let's go up here to our top. And let's get rid of this, because that's just a testing operator. And you notice we're getting a weird set of numbers in there. So let's go ahead and run it again. There we go, all in a nice line. So prime numbers between 1 and 100 are 1, 2, 3, 5, 7, 11, 13, 17, 19, etc. Now, I got you all the way to right here. Followed the same pattern. We can probably assume that's true all the way across. However, you can look it up. But like everything, we want it big. So let's see what happens when we run 600. And you notice it calculates quite quickly. Get this out of the way so we can see. So interesting enough, 500 has 1, 2, 3, 4. Now, so let's say that we want it to start here at 300. So let's go ahead and add one more variable in here. And we're going to say int start is equal to, so let's say we just want the numbers from 300 to 600. Now we can go ahead and let's see, how do we want to do this? In this case, it might be easier just to hard code this number. The reason is if we change that I, we have to change all those I's. And I'm on this trackball mouse because I don't have my normal one, and I'm not very good at it. So for today, we're just going to hard code in 300. But normally, if I was writing this, I would make another integer and make all of the I's the start, so that way it can count. All right, so let's go ahead and run it. So you notice it starts at 300 and ends at 599. So now in your math class, they say, well, what are your prime numbers between, let's do something interesting because I like big numbers. Let's say 35,869 and let's just go to 6 million. Now, is that 6 million? Yeah, that's 6 million. Let's see if we can crash it. All right, here goes. It's thinking. Did it crash? Yeah, we might have crashed it. Let's see what happens. Let's see. Let's go to 6. I think it's running. It's still running technically in the background. So let's stop it and shrink it down just a little bit. So you saw it pop up for a second, and then the computation is starting to get really big. And I don't know how to slow that down for visual. Thank you. But as you can see, we did get numbers. Let's make it a little smaller.
So you like big numbers, but that don't.
Well, they're actually, it's computing them. It just hasn't computed them all. And so in this case, we don't get to see them until it's done computing them. It'll pop up for a second. There's a surprising amount of very complicated mathematics and intensive power that goes in between computing prime numbers. In fact, there's many PhD mathematicians, that is all that they do is compute prime numbers. And right now, I forget what the largest prime number is. 5 points extra credit to anybody who Googles that and sends me the largest known prime number. Yeah, I want to write it right here so everybody can see it. Largest known prime number. 5 points. And this will go to the end of the grade. So, if you can find that. If you have about 50 supercomputers sitting at home, you could go ahead and calculate it and let it run for a few months and tell me what comes up if you want. But otherwise, I'd say Google and see what's there. All right. So we've went through a whole mess load of different little programs using for loops, while loops, and do while loops. Are there any other questions? Come on, people. Unmute them microphones if you need to. Spit them out.
There you go.
Send it to me. That's a pretty big number.
Do I get the points then?
If you send it to me,
Oh,
you gotta send it to me.
all right. Hold on. I got to log in.
Okay.
We take a snap of that.
Well, this is true, Stephen. However, there is a scientific notation for it, 2 to the such and such power, -1. So then you don't have to actually type the whole number. You can always copy and paste as well, or take me even a screenshot if you like. All right. Well, yep, that looks about right. So submit that to me in Canvas and you'll get your extra credit points.
Don't know it to you.
Well, you can email it to me however you want, just whichever way that I have access to it. All right, well, if there are no further questions, I'm going to conclude this Zoom chat. It will be available tomorrow online. And last chance for questions, Danielle, Juan. All righty. Well, let's stop the screen share and stop recording now.